dedicated to their professions, strive to make learning a fascinating journey and experience for all. The collaborations with universities in the US, UK, and Malaysia have added a whole new dimension to the KLE Society, making it on par with reputed educational institutions worldwide. The legacy of selfless service and sacrifice left behind by the founding fathers is pursued sincerely by the management to this day. Under the unparalleled leadership of Dr. Prabhakar Kore, the KLE institution has reached enviable heights. His spectacular chairmanship beyond 30 years with the active support of his team of elected members embodies the collective efforts of everyone in KLE, including more than 13,000 members of the trust, 110,262 students, and more than 16,000 strong faculty in making KLE an international education destination. Our college, that is KLE Society's SK Arts College, was established in the year 1952 with the munificent donation from His Holiness Sriman Maharaja Niranjan Jagadguru, Sri Guru Siddha Raj Yogendra Mahaswamiji of Moor Savira Mata Hubballi. The science wing was established in 1967 with a generous donation from Dr. Timmapanna Kausali. The college is a sprawling area of having more than 8 acres and situated in the heart of the city is imparting arts and science education to the needy students, especially from the rural sectors. Our college is providing the PG program in MSc. The college is accredited in 3 consecutive cycles with A grade by NAC. We are also working in participation with Unnat Bharat Abhiyan, MHRD, Swayam NPTEL, local chapter, Spoken Tutorial, IIT Bombay, MHRD Government of India, Institutions Innovation Council, MHRD Initiative, IIT Bombay Energy Swaraj Foundation, and recently we are proud to say that our college has been recognized as for the virtual lab under NITK Surathkal. We are having the more than 10 to 14 collaborators along the state as well as out of state. With this brief introduction, I welcome once again to all my dear students, delegates, and all the professors from the reputed universities and today's resource person, Dr. Dada Nade, for this wonderful program that is Ozone, a natural sunscreen. Thank you. Thank you, one and all.
Thank you, madam. I request Shri B.R. Jarkunte sir, Head of the Department of Geography, to introduce today's resource person. Over to you, sir.
Yes, thank you, madam. Hello, good morning, everyone. I, B.R. Jarkunte, Head Department of Geography, KLE Society SK Arts and SK Science Institute, Hubballi. It's give me an immense pleasure to introduce our eminent today's resource person, Dr. Dada Pandurang Nade, Head Department of Physics, Bharati Vidyapith, Dr. Patangarao Kadam Mahavidyalaya, Sangli, Maharashtra. Sir has done his PhD work in 2014 on the title of Study of Ionospheric Dynamics using Night Airglow Emission. In addition to this, sir has awarded various types of titles like Adarsha Yuva Puraskar by Prashik Welfare Association in the 2017, Research Assistant under the DST PURSE Department of Physics SUK, Young Scientist a Special Teacher Award in the 2018, Young Researcher by hands of Professor R.A. Mashelkar, Best Academic Performer Award in the 2019, and Best Researcher Award in the 2020. In addition to this, sir has given various book chapters like editor of the NCSAS 2019, a book abstract having ISBN number, and study of the equatorial plasma bubbles using GPS system has been accepted for the publications in the book under the working title Global Positioning System. That of this, sir has given published 32 reputed journals, 4 proceedings. Like this, sir has given 20 international conference, 20 national conference, and 17 national level, state level conferences, and 2 international workshops and 15 national level workshops. In addition to this, the sir has attended the 30 international webinars and 2 national webinars and 30 united talks and 12 articles in the Marathi language. Sir has also reviewer of the JGR, IJRS, IJRSP, JAS, JMS, JETAI. In addition to this, the sir organized events like that one day webinar on lightning day, ozone day, change the syllabus of the physics one day workshop on this one, and a national workshop on the space and atmospheric science, one day workshop on ozone day, national workshop on a new horizon in physics, joy of learning, one day workshop on international ozone day, one day workshop on international ozone day and solar summit 2K17, 2 weeks ISTE STTP workshop on engineering physics, reading motivational day, international space week, poster presentation in Vibrant 2015, FE parents meet 2015, and a guest lecture on India's in space by Professor Rajmal Jain. Sir, as also the professional body members like the member board of studies of physics, Sanjay Godawat University, Kolhapur, the lifetime member of the International Union of Radio Science, the lifetime member of the International Society for Research and Development, the lifetime member of the Marathi Vidyan Parishad, MUP, a member of the Indian Radio Science Society, a lifetime member of the Indian Meteorology Societies. So once again, I warmly welcome to our today's eminent resource person, Dr. Dada P. Nade. So I am now, with these few words, I am over to our Lakshmi Madam to this one. Thank you.
Thank you, sir. I request Dr. Dada P. Nade, sir, to start the technical session. Over to you, sir.
Okay. Thank you, sir, for a nice introduction. First of all, I would like to give a thanks to respected principal, Dr. Uma Nerle Madam, for giving this opportunity to be interact with you people and interaction with the Kaylee Society and this SK Arts College and HSK Science Institute. So this is, I suppose, to be a great opportunity to be for interaction with you as a resource person. Yes, thank you very much for this opportunity. I also thankful to Mr. Jarkunti sir for organizing this national seminar on this burning subject like ozone. So with this, I would like to share my presentation, and we will discuss here the topic that given by the organizing committee, that is ozone, nature, sunscreen. So my presentation is visible. So,
Yes, sir, visible.
yes,
Yes, sir. Yes, sir.
Yes, sir.
Sir, can you make it? Okay, full screen.
Yeah.
Okay, thank you, sir.
So this is the title is given by the organizing committee and the convener of this workshop, ozone, nature's sunscreen. So that we will discuss today how the ozone is nature's sunscreen. Okay, I will be give the short description, and this session I supposed to be interactive with the students. So let's we begin this. Yeah, this is the first question in mind. why we are using umbrella in the rainy season. So that picture itself representing the answer of this question. So the rainfall is coming from the sky, and that from protect from this rainfall, we are using the umbrella. Similarly, I have the another example. So this one, so the person who is driving the bike, and he has a helmet. So this helmet is doing the protection to the head of that person who is driving on the bike. So similarly, we are here on the earth, and this is because of somebody will suppose I ask a question to the students why we are live on the earth. So the people will or student will reply me like that. So because here the water is here or oxygen is here, and therefore we are live, or we, not only the human being, the all living organism is live on this earth because of the these two factors, mainly two factors, that is one is the oxygen and another one is the water. But my dear friends, so in that addition to that one, the ozone is there, and that ozone can protect us from the ultraviolet radiations which are coming from the sun. So this is the sun here, and that can be radiate the huge amount of radiations, and that can be protected by the ozone layer. So how the ozone layer protect us from the such radiations, that we will discuss today. And the title of this seminar is related to this one. So this layer is acts as a sunscreen. So the radiations coming from the sun, and this is the acts as a sunscreen, natural sunscreen. Okay, so therefore, so this title is given here for the seminar. So one by one we will discuss here. If you have doubts to the students, you can ask me anytime in while the presentation, no problem. Just stop me and ask me. Okay, one by one we will discuss. Okay, so before we discussion, we need to understand. I suppose to be the students are not exactly educated with this solar system and where is the Earth and how the atmosphere of the Earth, that we will first cover, and then we will go to the ozone. Okay, so this is the solar system. So this is the solar system picture, and this is the sun, and around the sun there are the 9 planets revolving around the sun. So these, uh, just for your information, just for your knowledge only, I'm telling you. So this is the first one is the Mercury, then second one is the Venus, third one is our Earth, and fourth one is the Mars. And then here started the Jupiter, the Saturn, Uranus, Neptune, and Pluto. So if you look at here, this one, Mercury, Venus, Earth, and Mars, these are rocky planets, and the Jupiters, Saturn, Uranus, Neptune, and Pluto, these are the gaseous planet, and in between there are the asteroid belt or comets. Some comets can coming towards the Earth as well. Some asteroids can come towards the Earth. Sometimes we can experience it as an in Marathi, Ulkapat. Okay, so that kind of the situation, or meteor shower, we can say that. So this can be happen due to the here there is a belt. So our Earth is at the third place from the sun, from the sun. Okay, so then if you look at here, so this picture, this is the sun, and sun can be radiate the huge amount of energy in the form of the plasma. So what happened in this case, if you look at here, is a very small point. So that point is nothing but our Earth. And this amount of energy when radiate from the sun, it can be interact with the Earth, but Earth has its own magnetic field. So this is the magnetic field of the Earth, and due to this magnetic field, so this plasma coming from the sun can be protect here only. So why I'm telling you, if you look at here, so if you compare this Earth and this much distance, it is too much. It is around Earth radii about 12 or something more than that. And if you go this side, so that Earth radii may be 25 or something more than that. Okay, so if you consider that, so this much energy already trapped here by the magnetic field lines, and then again it is a one more layer, that is the ozone layer, can protect us. How, we will discuss. Okay, so this is the only introductory part for you people. So magnetic fields also can be protected from the sun's radiation, sun's plasma, that is a huge plasma called as coronal mass ejection. So this is our beautiful Earth, and Earth has its own atmosphere. So that we will first discuss the what is meant by the atmosphere of the Earth. Okay, uh, because we need to understand atmosphere, then we will understand the ozone layer, where it is exactly, and how it can be create his how it can be do his work. Okay, that is very important. So here we will start with this, the sea level. From the sea level, if you look at here, the first layer is a troposphere. So troposphere, it is again depends upon the temperature. So this is the temperature line. So it is going on decreasing. If you look at here, so you will really understood that the temperature is goes on decreasing up to certain height. It up to, suppose it is a 15 kilometer, that is the troposphere, and the troposphere will stop here. So that is called as a tropopause. So that layer can be paused there, so that it is called as a tropopause. And again here another layer will start, and that is called as a stratosphere. So this is a stratosphere. Again here from tropopause, temperature goes on increasing, and it will be stopped somewhere here up to 50 or something like that, 60. That will be stopped, the temperature rising, and that portion or that position is called as a stratopause. And then again here it will be start decreasing the temperature, and somewhere it is a 90, 80 or something 100 kilometer, it will be one another pause, that is called as a mesopause, and this portion is called as a mesosphere. So here again it will be goes on increasing, and it may be the with respect to height, it's a very high temperature is present in the thermosphere. So it is, it depends upon the temperature only, rising temperature only or increasing temperature only, it is called as a thermosphere. And then it is up to 1,000 kilometer, it is a thermosphere. Above that, there is another layer that is called as the exosphere. We are not interested in the thermosphere and exosphere, but we are interested in the troposphere and stratosphere, how they are important for the ozone layer, that we will discuss. Okay, so this picture itself representing here another two region of the atmosphere. One is the homosphere and heterosphere. So homosphere, it is up to 80 kilometers. We are very much interested in this homosphere. Why? We will discuss. So if you look at here, this picture, so the Mount Everest height is around 8 to 9 kilometer, approximately in that layer. And if you look at here, around 25 kilometer, that is the one layer, and that layer is called as ozone layer. Okay, so ozone layer is a present in the stratosphere. Ozone layer is present in the stratosphere, where it is, you can now easily recognize where is the ozone. Okay, and there again, then some meteors shower, some polar lights and polar. So we are not interested in this. So you just can imagine that where is the ozone. Okay, so now we come to the point and we will discuss about only the ozone. So this is the ozone. I just put it here, the figure for the ozone. So this is the ozone can be start from this 0 to 40 kilometer altitude. And if you look at here, it will be start after 16 kilometer. It goes on increasing, and somewhere it maximum and goes on decreasing. What it represent? It represent the at around 25 kilometer, the high concentration of the ozone layer is found. Okay, so and another one part is up to 2 kilometer, 1 or 2 kilometer. That is another ozone that is called as tropospheric ozone. So there are two kind of the ozone present in the atmosphere. One is the tropospheric ozone, and another one is the stratospheric ozone. So I hope you understood that the two kind of the ozone and they are present in the atmosphere. The high concentration of the ozone is found at around 25 kilometer altitude, and it is a 1 or 2 kilometer up to 2 kilometer at the ground level. There is another ozone that is called as a tropospheric ozone, and this ozone is called as a stratospheric ozone. So this is the animated figure representing that. So this is the layer of the ozone, and if in case what happened, if it is a break, then what will be the happen on the earth? That is the representation of the figure. Okay. Now we move to towards the ozone formula and how it will be formed in the atmosphere. Okay, so first ozone and oxygen. So we already have discussed about that, why we are live on the earth. So the very simple reason is that there is a oxygen and water, and now we can say that there is a ozone also. So, so if you look at here, this figure, the oxygen atom, so this is the oxygen atom, and this is the oxygen molecule. So we know that. So this is the oxygen molecule, this is the atom, and if both combine together, it will be formed the ozone molecule. So ozone is nothing but O3. So that is the part of the oxygen only, or it can be formed due to the oxygen only. So we need to understood the how much quantity of the oxygen present in the atmosphere, and then how we can create or how the ozone molecule creates in the atmosphere. That is very important. So in 1840, this Fenrich have first discovered that in the laboratory the formula of the ozone molecule, or he has done that one work, and then it was the first invention or first discovery of the ozone. The ozone have an organic molecule, and it is chemical formula is O3. So now it's if you suppose that the 10 million year molecules, then out of 2 millions are normal oxygen, and about only 3 are ozone molecules. So can you imagine that? So 10 million air molecules. So many air molecules are there, and only out of that 2 millions are oxygen. That is this one, oxygen molecule. And only 3 molecules are the ozone molecules. So can you imagine that? So how the this much percentage? So if you go to the percentage is here, the 0.06% oxygen, sorry, ozone molecules are there, and they are protecting from the high energetic radiations of the coming from the sun to the surface of the earth. So this is a very important. Okay, So therefore, we will discuss the atmospheric constitutions, or we can say that the how many molecules are there, how many atoms are there present in the atmosphere, or so this is the gases present in the atmosphere. So main gases are there. One is the nitrogen, another one is the oxygen, and another one is the argon. So these are, if you look at a percentage here, the nitrogen have 78% present the nitrogen, 78. And if you look at the oxygen, oxygen is approximately 21% is the oxygen, and remaining 1% is the argon. And if you look at here, other category, that will be the 0.04, approximately 37 means I can say that 0.04% other elements are present in the atmosphere. Which are the other elements? So these are the other elements. This is a carbon dioxide, carbon monoxide, methane, hydrocarbons, and ozone, etc. So the ozone is also called as a greenhouse gas. That is called as a trace gases, we can say that. So you can imagine that how much concentration of the ozone present in the atmosphere, and that can help us to live on the earth. You just imagine that. Okay. So this is the chemical reaction for the production of the ozone. So this is a very complex reactions. I'm not going to the detail of the complex reactions because I know that you will people not understood, and that my presentation will be uh, bore if I explain these reactions. But you need to understand the concept of the this one. So it is a very simple concept. This is a radical, hydrogen radicals are there. So that can be interacts with the oxygen molecule with the some energy. So that will be form the ozone molecule. That will form the ozone molecule. So this is a simple reaction. Here also some carbon dioxide, then they can be interact with this oxygen molecule, and they can be form the O3. So these two kind of the reactions, and another two kind of the reactions are there, that is the NO rich environment, that is a nitrogen oxide environment, rich environment, and deficient environment. In both cases the ozone can be produced. Okay, or ozone here in this case ozone can be lost. Okay, so why I'm telling you this reaction, uh, because it is very important. We are the part of this system, and we are creating some kind of the molecules, or some kind of the particles, some kind of the pollutant, and that can be responsible for the ozone creation at the troposphere. I will go to there only, but don't worry about it. The Sydney Chapman in 1930, he has given that the simplest uh, reaction for the stratospheric ozone production. If you look at here, so this is the oxygen molecule. Oxygen molecule, if it interacts with the ultraviolet radiations, and then it will be formed the one oxygen atom, and here another oxygen atom. So these oxygen atoms again interact with the oxygen molecules, and they can be formed the ozone molecules. Ozone molecules. Okay. So this is overall reaction. So from the ozone only, so oxygen only, it can be from the O3. So this is the requirement, that is the sunlight. Requirement is the sunlight. So can you imagine that this portion of the stratospheric ozone is looking from the 15 kilometer to 40 kilometer, and the concentration is only at the 25 kilometer. So how this is the possible? So it is only possible because in that region only the ultraviolet radiation is coming, and they are trapped there. Trapped means they are utilized for the formation of the ozone. Oxygen can break there, and it can be formed the O3. So this O3 again protect us like that only. So they can be interact with there only. Okay. So please keep in mind. So this is the spectra. So solar radiation spectra, or you can say that ultraviolet radiation. Here, this is the ultraviolet radiation, and here the visible. Oh, sorry. Here the visible spectra, and this is the infrared. As we know that this portion is the ultraviolet radiation, we are talking about the ultraviolet radiation, but this portion, as we are aware about it, we can easily see the object which is around us. And infrared means it is a Mr. India, that is Anil Kapoor. Okay, so that light was used in that case. Okay, just for imagination. Yes. So now how these ultraviolet radiations come towards the surface, and how they can be interact with the oxygen molecules, and how they can be form the ozone that we have discussed. So look at here, you can easily understood that. So there are again three kind of the ultraviolet radiations: ultraviolet A, ultraviolet B, and ultraviolet C. Ultraviolet A can be reached to the surface. They have minimum energy, but the ultraviolet B have more than that energy, and ultraviolet C have more than A or B energy. So that their energy, with respect to their energy, here the oxygen molecules can be immediately converted into the ozone molecules. Okay, so it's a very simple theory behind it. Now, who first discovered that or measured the ozone? So this is the person that is called as a Dobson, and many institutes, that is ISRO or IITM Pune or IMD, they are using the Dobson spectrometer for measure the ozone. Nowadays we have the latest technology also of this latest version of the Dobson spectrometer we have. So this is called as a spectrophotometer, and at Oxford University he has invented in 1924. So it is called as a Dobson spectrometer or spectrophotometer, and the unit of the measurement for the ozone is used as a Dobson. Okay, so name of this person, that is a scientist. Okay, how many measurements techniques are there? So there are the measurement techniques are mainly three measurement techniques are there. One is the ground-based measurement techniques, then airborne, then satellite. So in ground-based measurement technique, Dobson spectrometer, then Breuil's spectrometer, and photometers. So the photometer, we had used that photometer, and one of the instrument I'm handling that one, that is called as a microtop second ozonometer that we are using. And now this instrument is available in the Sanjay Gulab University. This airborne measurements, that is the balloon, ozone rockets, and aircrafts. So IITM Pune people are using the aircrafts measurements. Rocket measurements are most of the times they are using in the USA, and balloon ozone sonde. So this can be measured. That is this is this one that is used in the NARL, that is the lab of the ISRO, which is placed in the Gadanki near to the Tirupati. So there, the scientists are using this one, the balloon ozone sonde. Then satellite measurement techniques, that is a total ozone mapping spectrometer, TOMS, and these two satellites are now under the NASA. Okay. no subtle is there. So they are regularly measuring the ozone concentration of the atmosphere, and this data is again available for the uh, research purpose. You can use it. Okay. So now we come to the point, that is the ozone hole, and why the people are going to the work on this ozone. So this is the Joseph Farman, and he has detected 35% of the ozone loss over the Antarctica during the springtime. Okay, so he was leaded the British group, and he person here, and he has this is the Dobson spectrometer again. He has used to measure that ozone, and then after this group, there are the satellites by the NASA, and again the Japanese satellites. They have sent their satellites, and they have recorded the measurements of the ozone, and they found that there is some gap. There is some gap here in this. In 1970 to here we go to the 2013. If you go clearly observe that here there is a nothing is a gap, but it gap was started in 1979, and in 2007, in 2009, in 2011, 2013, it looks like a some gap. It looks like that is a 35% gap. So that was detected by the Joseph, and then there was started the work on the this particularly topic, that is called as ozone, and nowadays it is a burning topic of the research. Okay, so I will explain you what it means that exactly, and how we will get that kind of the graph. I will show you. Okay, so this, if you look at here this picture, uh, yes, here this is the data, and it's a yearly data, yearly average data, and in 2020, okay, here another one in 2019. So if you look at here how the looks like this, uh, okay, and if you clearly see that this picture, so you can realize that the ozone hole is going to recovery. Again, I have one more video here, so that will be representing the July to August and September 2021. Similarly, I have the for the November. So what will be the picture looks like, what it indicates, that we will be discuss. Okay. One second. So if you look at here, you can realize that this picture, that is the area of the ozone layer at the southern hemisphere here, and in this particularly May 31st May 2020 and 31st May 2021. So there is a nothing. There is a nothing. Here is nothing. Means there is a ozone is there. Ozone is there. Here also ozone is there. But in September, there is a ozone hole is looking like this. Okay. Ozone hole is here. Okay. So we will discuss. Okay. Just oh. Okay, how we can create the graph now. So this is again very important. If you are some people are want to do the research on this particular topic, or if somebody want to do the project, some MSc student or BSc student want to do the project, so for that only this figure, how we can read it, or how we can plot the graph, so that is the nature, it will be looks like that here. So their area, illuminated area is like that. This area is goes on increasing from the August to October, November, December. So it will, it shows that it is on is a high area, illuminated area is high in the September or September, October. And if it is a minimum ozone column, so that is looking here. So in that area is a very minimum ozone present in this particularly days. Okay, so the graph, I have the graph also, I will show you. This figure shows that this is the Tom's OMI and OMPS data. So this data is again available on the website of the NASA. You can go there, you can download, you can do the research, you can do your interpretation regarding the same. But they have already done the job from 1979 to 2021. Okay, so they have already done what they have found. So they found that there is this gap area, so that was we have seen that. So that was in the September, it was a high, that area was a high in a September, it looks like that. Okay, and corresponding ozone depletion or ozone minimum was also found in that particularly period, that is in September October period. It was very low. Similarly here, the how much ozone was present in that case, that is given in this two figure. Okay, so that representing that September October, and during the September October, that ozone was very low. For confirmation, I want to show you the figures. If you look at here from January to December, so in January there is nothing, so ozone was there. So small portion is there, only small portion is there. But if you March, April, May, June, July, August, there is nothing. Here, August, some portion looks like a dark. Yeah, this is the blue darks. So that representing the whole of the ozone hole, we can say that. Okay, somebody want to ask the question? Yes, uh, sir, anybody want to question, you can ask me anytime. Hello, Charkunti sir, if somebody want to ask the question, you can please tell me. If anybody want to ask the question, you can ask me directly, or sir can ask me. If you have any doubt, somebody raising the hand.
Yes, sir. Someone has raised the hand. If you want to ask the question, please go.
Yes, please. Or they can be asked. Yes. Have any question? Or shall I continue?
Yes, sir. Continue, sir.
Okay. So here you can. I try my best to describe you the all these concept. Okay. So this is the September October. If you look at here, so that whole is high and then it goes on again decreasing. So basis on this. So if we look at here the same picture, and here from again we have already discussed here some kind of the in September and October, and in October again in this is October. So in this period, so ozone hole is looks like that. Okay, particularly. And last year, what happened in last 2 years, we are facing the problem of the corona. So during that pandemic period, what happened? So this environment is very clear, and due to that only, the suns can radiate the energy again. The oxygen can be converted into the ozone, and then this process goes on very smoothly. there is nothing, any additional obstacle is there. Okay, so that due to that condition, the scientists have reported that this March 2020, that ozone hole goes on a recovery. So, but there again the question is the same. This figure was the from the March month, but in September and October, if you look at September, October, so that again it shows the some ozone hole. So this is the again question mark. Is there any other natural phenomena is involved in the happening the ozone hole? Is it some kind of the activities going on there? That is the again question mark. Okay, so when this was started actually, so that I will explain you. In 1974, the Ronald and Molina discovered that the CFC, so chlorofluorocarbon, we can say that chlorofluorocarbon can destroy the ozone in the stratosphere. So that was the reported by the Ronald and Molina with the theoretical concept. Okay. After that, in 1986, the Solomon published her theory on the how the CFC can cause the ozone hole, and she has taken the actual reading in the southern hemisphere, and she has published his paper in the Nature Journal of Nature. So then, after his publication, these people got that Nobel Prize for the study of the ozone layer, and you can surprise that. So after that, after her paper, these two people, Ronald and Molina, got that Nobel Prize for the study of the ozone layer in the Antarctica. Okay, so this is a very fantastic story behind it. Okay, then how the CFC can destroy the ozone layer, that we will discuss here. So it's very simple theory. I will explain you. So this is the chlorofluorocarbon, that is CFC molecule, and when the sunlight is coming and in fall on that CFC, then what happened? It is some chlorine can be come out or break out from this one, and this chlorine can again interacts with the ozone. So what happened in this case? Again, it will be interact with the one oxygen atom here, one oxygen atom, and then it will be form the oxygen molecule. So this oxygen atom, again, there is some free atoms are there, because this is the again simultaneously process is that this oxygen molecule can be break to the due to the ultraviolet radiation. So there is again free oxygen atom can be interact with this one, that is the chloride monoxide. Okay, so this chlorine monoxide and this free oxygen, they can be interact, and here the chlorine will be come out, and there again form the oxygen molecule. It's very simple. So this CFC is acts as a only catalyst in this reaction, and it can be formed the from the ozone to oxygen molecule. It's very simple. So that what happened in that particular region, if the CFC is high, in that case the ozone can be break and oxygen will be formed. Okay, so this is a very simple theory, and it is acts as a catalyst. So for this theory, they got that Nobel Prize. So who will produce the such kind of the molecules? Okay, so you look at this figure. This figure itself representing. So this is the pollution by the industrialization. Then we are using the sprays. So there are the number of sprays, the color spray, or no, so many sprays are there. So then we are using the fridge, then space shuttle and rockets, then air conditioners, then transportation. So all the parameters are equally contributing to produce the CFC. Then what we can do that? What we will do? So how we can protect our ozone layer at that Antarctica or hemisphere? So that is a question mark. So for that only we can do that. Okay, how it will be formed, and then we will discuss what we will do that. Okay, so what happened if this goes on increasing, then CFC goes on increasing. If the CFC goes on increasing, then ozone will be decreasing. If ozone will be decreasing, the direct radiations from the sun will reach to the surface of the earth, and they these radiations are responsible for the cancer. So this is the eye cancer, DNA cancer, then skin cancer. So many types of the cancers are there. For example, if you take the example of the Canada, so in Canada there are so many cases are there. So their faces or their skins are uh, damaged due to the ultraviolet radiations. Some region the DNA damaged means what means it means that some kind of the uh, एक ही आदमी को 3 हाथ निकलते हैं, 4 उंगलियां होती है, 6 उंगलियां होती है, 12 उंगलियां होती है, ऐसा कुछ अलग अलग दिखाई देता है. So that kind of the picture, that kind of the situation can be found in that in this on the earth due to the high ultraviolet radiations. And not only human, but also on the plants, also on the sea, there is affected. So this is the ultraviolet B radiation damage the crops. Okay, so some here we can see the melting of the ice, and this picture is evidence of that one. So so many people are talking about the greenhouse gases, then melting of ice, then heating of the earth. So these all are related to the ozone. All are related to the ozone. Okay, so please keep in mind. So to protect this one, so who will take the decision? Who will come out with the solution? So they have solution. So what is the solution? Solution is the Montreal Protocol. So this is a very important thing. In 1987, okay, in 1987, Montreal Protocol was signed, and they have signed with many countries involved in this particularly protocol, and they have listed some molecules, some what I call ozone depleting substances, and these are the ozone depleting substances. Yes, and we means people uh, for industrialization, for the other purpose, we are purposefully we are producing these ozone depleting substances. Which are they? So the list is given here: CFC, then halon, then methyl, then carbo methyl methyl bromide, then HS HCFC. So these are the so many what I call substances. These are produced by the man-made activities like a refrigerator, then some vehicles. So these can be stopped, can be protected by the new methodology. By the new method means we can use the electrical vehicle, we can use the solar energy, so that can we can protect ourselves, or we can protect our ozone by protecting this production of the ozone depleting substances. So we can do that, we have the capacity. Okay, so now I move to the So this is the protocol, and I would like to say that here our country, that is India, also the part of the Montreal Protocol, and we have already banned to the this kind of the substances which are responsible for the depleting of the ozone. We already done that, and in 2030, the our country has aimed to completely ban such a on the production of the such substances. While we can look at here, so this is the global uh, concentration of the ozone. So here the concentration of the ozone is a very low in this particular region, and if you look at here, so their concentration is very low in the hill region, that is in Himalaya or in that particular region. Okay, ozone. We had done ourselves some research work. This is my paper actually published in the uh, Springer journal. Okay, so what we did that taken some places from the India, like that here, some place from 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 here. So we have considered that. So these are the uh, places. So like on Trivandrum, then Pune, then Madhya Pradesh, then Delhi, and then Srinagar, like that. So we just take that to the longitudinal variation of the ozone, and we had checked it. So we found that there is a trend in the ozone. So that trend in the ozone with respect to the solar cycle, and that we found that in 1986 to 1997, that trend goes on decreasing. What it means that uh, that is a ozone level was in decreasing the order, but in the September 1997 to 2008, it wasn't normal. It was normal. And 2008 to 2015, it was goes on. It's a increasing trend. What it means that? It means that the ozone is goes on increasing trend. For the Trivandrum, similarly, we found that for Pune in Maharashtra and for the Delhi. So it is a same nature, we found that. So it means that the Montreal Protocol is working successfully in the India. Okay. So now we have discussed about the stratospheric ozone. Now there is another ozone that is called as a bad ozone. So we have discussed about the good ozone and what we can do, that we have discussed. And now within 5 minutes, I will show you the bad ozone and how it will be affect on our body. So again, it is a reaction. I'm not going to the details of reaction. Okay, so look at this figure. So it's a very simple reaction. So this is the atmospheric oxygen which is present in the atmosphere, and then nitrogen oxides are here, which are mainly produced due to the lightning and other activities, or in a case of the high polluted areas. Then volatile organic compounds. So volatile organic compounds can be produced by the industry, or maybe in volcanic process, maybe in other activities, that is transportation and all these things. So they are involved in this production of the volatile organic compounds. So when these are combined together, it will be form the ozone. My dear friends, this ozone is a very, very bad for us, because we need oxygen. We, we do not require the ozone. We need oxygen only. We need oxygen. But here what happened in the this 2 kilometer or 1 kilometer altitude, this portion is uh, must be oxygen reached, not ozone reached. If it is found ozone, then what happened? This ozone means it can be convert the oxygen into the ozone. So we need some cylinders, oxygen cylinder. Like in pandemic situation, we had seen that problem. Okay, and continuously we have been looking the person who is facing the problem of the COVID-19. Then the person required the oxygen in cylinder. Okay, so that we need to take care about this particularly ozone. We uh, protect to oxygen from the ozone. Okay, so तो यहाँ पर ओजोन नहीं होना चाहिए. यहाँ पर अगर ओजोन हो जाएगा तो हमारे हेल्थ के लिए बहुत प्रॉब्लम हो जाएगी. और दिस इज हैपनिंग बिकॉज ऑफ द इंडस्ट्री ओनली, बिकॉज ऑफ द इंडस्ट्री एंड transportation, all these things. Okay, so we need to protect our city, protect our town. Okay, what will be the happen with this particularly? So there are so many effects, uh, of the stratospheric ozone, so that listed here. I'm not going to the detail, but I will tell you. So breathing problem is a major problem of the because of the only ozone. So in this pandemic situation, if the concentration of ozone goes on increasing, then it will be very harmful for our health. We already done that research, and we found that due to the fires, that surface ozone goes on increasing. That was a study was already done in the Colombo city, and we have already reported that. Okay, so please be careful about it, and do not produce the ozone at surface level. Okay, so don't I just finally I would like to say, don't buy the aerosol product. Aerosol product means these are like an chlorofluorocarbon. Then dispose of the pre 1995 refrigerator, fridge, air conditions. Okay, so these materials, if you have in your home, so please dispose it, destroy it properly. Okay, drive less, walk more, plant more trees as you can. So this is a very important. Plant more, because plant can be produce the oxygen, and this is oxygen, we need oxygen. Okay, developing strict regulation for the rocket launches. The already government have done the policies. Okay, and I say thank you very much, all of you, for this lecture. Okay, if you have any doubt, you can ask me. No, somebody have doubt? Ask.
If any of the delegates have questions, please ask. If any of the delegates have questions, you can ask.
Yes.
Sir, Shri Jarkonte sir have one question, sir.
Yes, please. Yes, sir, please. Hello.
Yes, sir, he will ask, sir.
Yes, please.
Hello, sir.
Yes, please, sir.
Yes, sir. Some students are posted the 2-3 questions. Just I will read out this one, sir.
Yes, please.
Sir, how is ozone measured in the atmosphere? It is one, sir.
Okay.
The second one is why
has an ozone hole appeared over the Antarctic when ozone depleting substances are present throughout the stratosphere? These two questions.
Okay, first question is that how to measure the ozone. So this is the answer is this very simple. Sorry, I did not tell it during my presentation. Actually, what happened when the sun's radiation is coming? My presentation is visible. Hello, sir.
Yes, sir, it's visible.
Okay. Yeah. So here. Yes. So what happened in this case, how to measure the ozone? So when we are not we exactly measure the ozone, but we are measuring the concentration of ultraviolet radiations. We know that the ultraviolet radiations and their frequencies. So in this case, we can measure the ultraviolet radiations which are coming from the sun at the surface of the earth, here surface of the earth, and then this is called as a total column ozone. So it is called as a total column ozone. So basis on that ultraviolet radiation, there is some formulas are there. So by using these formulae we can calculate the concentration of the ozone. This is a one method. Another method is that the balloon method. I already explained that. So this is the balloon method. In that balloon method, we can use the ozone detector, means ozone sensor we can use here, and that sense the O3 only. So that is by the smell or some activities we can measure it. So we can send the balloon in the atmosphere. So it goes to the up level. Okay, and it can be sensed, and that through the GPS we can record it on the our computer system. So these are the two methods we can use for the measurement of the ozone. Sorry, sir. Second question. Okay, is it clear, sir?
Yes, sir, it is visible, sir.
I just answered
Yes,
the question. Is it clear?
Yes, sir. Yes, sir, it is clear, sir.
Okay. So second question.
Why has an ozone hole appeared over Antarctica when ozone depleting substances are present throughout the stratosphere?
Yes, exactly. So for that, I need to explain the rotation of the Earth, and there some what I call wind circulations are there. So there are the three circulation or wind circulations are there at the equator, mid latitude, and high latitude. So these wind circulations can be circulate these CFC molecules or other ozone depleting substances. They can be moved with that wind, and they can be go there in the Antarctica. Why in Antarctica only? Because if you look at the portion of the pole region only, in this south side and north side, so there is the only 6 month is the radiations coming from the sun, and 6 months there is nothing, no radiations. So that kind of the situation is there only, and therefore we can observe the ozone hole. Means 6 months only we there, so solar radiations can be incident on that particularly region, and whenever the solar radiations incident, then there is some reaction found. So that I will already explain that, and due to that reason only, the hemisphere, that is a whole region only, appears the ozone hole. Okay. Do you understand this one?
Yes, sir. And there is another question, sir.
Yes, please. Yes,
So
please.
it is asked by Mr. Muthu. So he has asked, under the Montreal Protocol, the target for developing countries is by 2028. So next 30 years, how we could replace the CFCs?
Yes, it is a good question, because what happened in this case, we are actually trying to minimize the substances which are depleting the ozone layer. So we have already almost at the that level. You people may be aware about that. The policy of the government is very clear, and they have declared the electrical vehicles and natural gas vehicles in the they have permitted. So they have already stopped the vehicles which are depending on the diesel. So the slowly this up to 2030 it will be possible to stop the such kind of the substances, production of the substances. Yes, we can do that.
Thank you, sir.
I will show you one figure that will be representing the
Sir, shall we move
yes.
on?
Yes, please.
Okay. So now it is the time for having a group photo. So I request everyone to switch on their video. Please, everyone switch on your video.
Shall I stop my sharing?
Yes, sir.
Here only. Okay, stop sharing. Okay, good. Okay, before wind up, I would like to say something. So I'm just madam is there? Oh, madam is there? Nerle madam is there?
Yes, sir. Yes, sir.
Okay. So once again, I would like to say thank you to all the members of this organizing committee members and principal ma'am, Nerle madam, for giving this opportunity, and also thankful to our ex vice chancellor, Dr. Riker sir. He has given me opportunity to interact with these people. He is a great leader, I would like to say, because he has motivational person for me, and he has given me a lot of chance to do such work in the Sanjay Godavat University. Okay, I'm very much thankful to him. Okay, now you can take the photo. Thank you, one and all.
Thank you, sir. Okay. Thank you very much, sir, for such a informative and wonderful talk, sir. Now I request Shri Shanu Jamkandi, sir, to propose vote of thanks. Over to you, sir.
Thank you, ma'am. Hello. Thank you, ma'am. Good afternoon to all. I am Shanu Jamkandi, Faculty of Department of Geography. As all good things come to an end through this national level webinar, I take this opportunity to propose vote of thanks to those who have directly and indirectly contributed to the success of today's national level webinar. At the outset, I immensely thank our eminent resource person, Dr. Dada Panduranga Nade, Head Department of Physics, Bharati Vidyapeeth, Dr. Patangrao Kadam Mahavidyalaya, Sangli, Maharashtra. Sir, we are greatly enlightened by your knowledge and ideas presented in the national level webinar. It is highly useful and beneficial to the teaching and students community. Thank you so much, sir. I thank to our beloved principal, Dr. Uma V. Nile ma'am, for her motivation to organize this webinar. Thank you, ma'am. I also thank to Ms. Nazneen Ismail Sheikh, Student Secretary, and Dr. Lakshmi Jatin Gaudar, Master of this ceremony, who helped to organize and successfully completion of today's national level webinar. I express my gratitude to all the teaching and non-teaching staff for unflinching support and coordination. Our heartfelt thanks to all the participants and students for their live active participation in this webinar. With these warm words and kind message, we move to the end of today's national level webinar. Thank you, one and all.
Thank you.
Thank you, Shanur, sir. I request everyone to fill the feedback form which is given in the chat box.
Okay, shall I leave?
Yes, sir. Thank you very much, sir.
Thank you.